Hey, guys. So this is what we're going to be doing today. First of all, we got to get our minds right. So this is y'all get your mind right then. So I need y'all to do that for me, okay? Anyway, moving right along. We are still on chapter 13, and our lecture today is going to be on bundle branch block. Okay, so here's the illustration of the area that we're going to be looking at. Here we see our SA node is firing and coming down through the bundle branch and down through the Purkinje fibers. Okay. So the leads we're gonna be looking at on the EKG for your bundle branch blocks is gonna be V1 and V6. The objective we're going to cover in this lecture is going to be to determine if you have a right or left bundle branch block. This is just another illustration of our firing an electrical signal going through from the SA node through the through down to the Lord, I can't talk today. Down through the ventricles. Okay. So here again, another illustration of where we're going to be, the area we're going to be talking about. So let's talk about what a bundle branch block is. A bundle branch block is a blockage in either the left or right bundle branch. Because of the block, the electrical signal that usually causes both the ventricles to contract together are now out of sync. Okay. This diagram shows the block being on the left ventricle, which delays the contraction on that side, while the impulse traveling to the unaffected side flows through and contracts the right ventricle on time. As a result, the contraction of the ventricle is delayed and the other side is not. So when you see it on the EKG graph, this creates two separate QRS intervals overlapping from them being out of sync. If you look down here, it looks like it gives you two QRS waves. Okay. So on the EKG strip, this is what it's going to look like. Overall, the contraction takes longer and the QRS measures wider at 0.12 or greater. Okay, and I'll show y'all what that measurement looks like in a later slide. Again, another view of the areas we're looking at. Here, if you have a block on this side, it illustrates your right bundle branch, and the blue illustration on this side shows your left bundle branch. Bundle branch blocks or conduction in the bundle branches and Purkinje fibers are seen as QRS complex on the ECG. Okay. Therefore, a conduction block of the bundle branches would be reflected as a change in your QRS. Okay, so here, that's what we're going to be looking at. We're going to be looking at our QRS complex in V1 and V6 on the strip. With bundle branch blocks, you will see two changes on the EKG or ECG. The QRS complex is going to be widened, so it's going to be greater than 0.12 seconds. And the QRS morphology changes, and that it varies depending on the ECG lead and if it is a right or left bundle branch block. Okay. So let's look at what is normal measurement for our QRS complex. So normally our QRS complex measures only about 2 to 3 small blocks, okay, or 0.08 seconds to 0.12 seconds. And here, if you look over here at the heartbeat here, you can see that 1 or 2 blocks. So what happens to the right and left ventricle depolarization if one bundle branch is blocked? What do you suspect the QRS complex may look like? Sorry, guys, let me get back to where we were. Okay. So that QRS complex is going to widen. Okay, and you're going to see what looks like, what gives you the view of the right and left ventricle contracting out of sync. So here's an illustration where you can clearly see that that QRS complex is at least 3 squares or greater than 3 squares. So now we're going to go into the characteristics of having a right bundle branch block. So to determine if you have a right bundle branch block, you're going to look in V1 and V2. Okay, let's look at V1. See our double R. And then here we see in V2. And then you're going to also look in V5 and V6 for that slurred S wave. See here, you see the dip in the S in V5 and 6. Okay. So here, characteristics of a right bundle branch block. Here's where an illustration of where that block would be. And again, here's a deflection of what that QRS will look like. Now you guys will need to take notes on this stuff. And again, like I said, it's something that you're going to have to practice. And of course, if you have any questions, I am always available to help you. So anytime you need, just give me a call. So our ECG for the right bundle branch, the QRS is going to be greater than or equal to 0.12 seconds with the mid-final slurs. V1 has the RSR with slurred R wave and a negative T wave. M-shaped like a rabbit ear pattern. Okay. V6, your QRS with evident S wave slurring and positive T wave. Okay. See here our S is slurring, and then here's our T wave pointing upward. Okay. But look at our T wave in V1. AVR, the QR with evident R wave slurring and negative T wave. And then the T wave with its polarity opposed to the QRS slurring. Okay, so what that's saying is your T wave is going to be pointing in the opposite direction of your QRS. Here's just another illustration of that. V1 shows an RSR pattern. And here we see that, RSR. And V1 will be positively deflected, which is not normal. Okay. So your V1 should be negative, okay, but it's showing it has a positive deflection as well. And if you look in lead 6, V6, you see the slurred S wave. Okay, here again, and y'all know I like to give different illustrations so that everybody has a different view of it. So again, you're going to choose which slide best illustrates it to you in a way that you can understand it, and then you just go with that slide and to help you, okay? So here, this is just another illustration of our V1 and V6 for a right bundle branch. Oh, cannot talk today. Right bundle branch block. Okay, so let's look at it on a real EKG strip. We're looking in V1. Here we see our complex here. And then if we look over in V6, here we see that slurred S. And you can also see it in V1. Okay, so your right bundle branch block criteria, your QRS is going to be greater than or equal to 110 milliseconds. Your RSR pattern is going to have, it's going to look like a notched R. Remember we looked at that on the previous slide. And then you'll have, of course, the wide slurred S in V6. Here's another comparison to your normal, what's normal for a right bundle branch block. Okay, so moving right along, let's talk about our left bundle branch block criteria. So for the left bundle branch block, you're going to look in V5 and V6 and or lead 1. And your QRS is going to be blunted or stubby looking. Okay. If you look in V1 through V3, your QRS is going to be predominantly negative, and we see our R pointing downward. So this is a illustration of an example of where that left bundle branch block may be located. Okay, here is an illustration of a better illustration of the widening of the QRS and how you would measure that. So when you're looking at that strip, you see that QRS is greater. It's either 3 blocks or greater. Okay. And of course, we know our normal is, the normal is usually, is usually between 1 and 2 blocks is what you'll usually see. Okay, so let's look at what our QRS looks like in V1 and V6 for a normal heartbeat. We see our QRS is, deflection is negative in V1 and positive in V6. Look at it here for our right bundle branch block. We have the R on R. And then over here in V6, we see the slurred S wave. And then in our left bundle branch block, we have the QRS deflection with the double R pointing negative. And then you see over in V6, again, you have the slurred, you have the inverted T wave. Get back to, okay, here yet again, just another view. Same thing. And like I said, the highlighted area is what you'll be looking at in these leads. So again, you just choose the slide that best speaks to you, and then you're going to make you an illustration of that slide for your reference and your study material. Okay. Here again, another view. So and these are your QRS complex, okay? So for our right bundle branch block, see the double R's. That shorter one being your left ventricle and the taller one being the right ventricle. And then for the left bundle branch block, you'll see what like looks like it has a C shape, an inverted C shape. Okay, so let's talk about some common characteristics of both. So with all your bundle branch blocks, you will have a QRS interval that is greater than or equal to 0.12 seconds, and a T wave that slopes off opposite the terminal uh, R wave. It should be an R right there, the terminal R wave of the QRS complex. So if you see figure 13-4 and 13-5, as well as 13-7 in your book, it will show you illustrations of that. Okay. You can also refer back to the slide in which I showed you the T-wave illustration. Okay, you got this, you guys. So your assignment is going to be to choose that slide that is most helpful to you in determining whether you have a right or left bundle branch block on your EKG, and you're going to recreate. I don't know what is the problem today. I cannot talk today. Excuse me, you guys. But you're going to recreate your version of that slide for your reference and your study material, and then submit your picture. Okay, that's all I have for you guys today. I will see you tomorrow. Goodbye.